Welcome to our presentation. Our project is on online flight delay prediction. One motivation for this project is that over $32 billion every year in the United States is spent on flight delays. And half of that cost actually goes into our flight tickets. Being able to predict flight delays accurately can be a huge resource saver. Here's the agenda of the day, and the first thing we'll talk about is the data set. We obtain our data from publicly available sources like the Department of Transportation. We have two data sets in our experiments. First is Pittsburgh outbound flights during September 2015, and there are roughly 2,000 flights. Second is JFK outbound flights during February 2015, and there are roughly 7,000 flights. In our data sets, there are quite a bit of nonlinear features, including day of month, airline ID, and flight numbers. We would like to convert these nonlinear features into linear features to be able to use them in our algorithms. One way we do that is through binarization. We turn one feature into multiple features that correspond to the original values. The first online algorithm we will talk about is generalized weighted majority. In our implementation, there are 3 experts, 2 naive experts and 1 expert that predicts based on the most relevant features, such as heavy rain or heavy wind. Basically, the weights of the experts represent a multinomial distribution. The second algorithm is online support vector machine. We apply iteratively a gradient descent process to reach an optimal weight vector. And the third algorithm is kernelized perceptron. We experimented with several different kernels, and RBF kernels seem to give us the best results. Last but not least, we looked at the winnow algorithm. One key feature of winnow algorithm is that it's able to separate relevant features from irrelevant features, and this is done through a multiplicative update process. We also looked at a few benchmarks. One of our benchmark is naive classifier. It's basically an expert that always predicts no delay. This classifier will give us a better sense of how our data set is looking in terms of the labels. The first offline algorithm we used is linear regression. It's basically an application of the backslash in MATLAB. It is fast, but this algorithm is hard to scale to a large amount of data in terms of their runtime and memory consumption. The second algorithm is linear SVM. Again, we're applying MATLAB's built-in function to perform this algorithm. It also has the same problem with scalability. Here's a table summarizing our results between our online and offline algorithms. The first observation we make is that offline algorithms generally perform better than online algorithms. But we can also see that offline algorithms run slower than online algorithms even at a data set of our size. With more data, online algorithms will run even much faster than offline algorithms. Here's 2 plots that summarize the convergence of our online algorithms. We can see that roughly with 1,000 flight data, our online algorithms can converge to some pretty stable accuracies. This also shows the adaptability to converge to the distribution in our data sets. Some future work. First, we really like to improve our data by obtaining additional data and selecting better features for our algorithms. We also like to compare online algorithms to offline algorithms in terms of scalability. This will further show the advantage of online algorithms against offline algorithms in terms of scalability. And that's it. Thank you for watching.